Write out this table taking the n values up to 20. You should have ended up with something like this. I'd suggest you try to learn and memorise all the square numbers up to 12 squared is 144, and the cube numbers up to at least 5 cubed, which is 125. Any more would be a bonus. It's useful to know these, especially for the non-calculator paper, so that if a number comes up that is a square or a cube, you'll recognise it's that, which could give you a key to solving some of the problems you'll encounter in the GCSEs. Pause the video and have a go at these questions. You should have found that all of the numbers were either a square or a cube or both. You might have also noticed some other facts, like that 81 is also a power of 4. 3 to the power of 4 is 81, so the fourth root of 81 is 3. And 64 is actually 2 to the power of 6, so the sixth root of 64 is also an integer. It might be worth pointing out at this time the thing about the square root symbol. The square root symbol means the positive square root of a number. You'll remember when we're solving an equation, like say x squared is 9, when we solve that we get x equals plus or minus 3. And yet here I haven't written root 81 is plus or minus 9, or root 64 is plus or minus 8, and so on. The reason for this is that the missing step that would go here would be that x is plus or minus the square root of 9. The square root symbol itself means the positive square root of. So if we just write the positive square root symbol, it's just the positive number. The problem comes when you hear a question verbally. If someone said, what is the square root of 64? Well, there are two square roots of 64, 8 and minus 8. If someone writes down root 64 like this, it means the positive square root. Have a look at this example and see if you can use it to answer the questions. Here are the answers. You probably need to pause the video to check them. Just to point out one of the cube numbers, for an example, we had 216 ends up being a cube number because you can split its prime factorisation into one number times itself again. So the cube root is 2 times 3, which is 6. Pause the video, have a go at these. Here are the answers. Pause the video again, have a go at these. And here are the answers. Pause the video, have a go at these. So, hopefully you realised that we've got minus 1 to the power of 1 is just minus 1. Minus 1 squared, a negative times a negative makes a positive. And then if you times that by minus 1 again, you get minus 1. Times minus 1 again, negative times a negative is a positive. And hopefully you noticed the pattern of alternating between negative numbers for the odd powers of 1 and positive 1 for the even powers of 1. So you should straight away, without doing a calculation, be able to write down these values. Minus 1 to the power of 6, 6 is even, so that's 1. Minus 1 to the power of 11, 11 is odd, so that's minus 1. And finally, minus 1 to the power of 204, an even number, is 1. Pause the video, have a look at these. You can try some other numbers too. So the 2s were given, the 5s and the 10s, not particularly interesting, but a useful check for divisibility. Powers of 5 always end in a 5, and powers of 10 always end in a 0. For the other numbers, 3 and 8 are quite similar to 2 in that they rotate around different numbers. So 3, we have 9, 7, 1, 3, 9, 7, 1, 3 in a repeating pattern. And for 8, same sort of thing with 4, 2, 6, 8, 4, 2, 6, 8. 4 wasn't on the list, but one that's quite interesting. It just has two different values. The last digit of the powers of 4 alternate between 6 and 4. Pause the video and have a go at these. So whichever method you used, you'll probably have come up with the same estimates. So probably the most obvious was to take 890 is 8.9 times 100, and then 8.9 is roughly 9, and we know the square root of 9 is 3. The square root of 100 is 10, so the answer would be roughly 30. Same sort of approach for each of them. Ones with a cube number, it would make sense to do exactly the same sort of thing. So here 611 cubed is about 6 times 100 cubed, and 6 cubed is 216, and 100 cubed would be 1,000,000. So we get 2,160,000. So we're about to move on to standard form. I really recommend you look at this website, which you'll find at scaleoftheuniverse.com. What it does is gives you an idea of really why we might want to use standard form and some examples of things at different sizes. If we start off here, this is things of about 1 metre, and you can see this human is almost 2 metres tall, but I can scale out to see things where instead of being 1 metre, we might want to be perhaps 1,000 metres, or further out, 1,000,000 metres. We're still kind of on the scale of countries on the earth. You can keep going, and what you'll notice as we go, the power of 10 is shown at the bottom of the screen, and we start going into planets, and it goes out to stars, and eventually I think we get towards galaxies and all sorts of things. On the other hand, we can go back in the other direction. So if I take us back to sort of getting into things we might recognise and human size, and then if we keep going, you'll notice the powers of 10 are negative here. We start getting towards smaller things. So we're going, there's an ant, getting smaller and smaller into different kind of particles. Width of a human hair, thickness of a piece of paper. We're now at negative powers around -3, -4, and if we keep going, you'll notice there's a long way on this scroll bar to go, right down into parts of atoms, splitting things up, getting smaller and smaller. This website's really good because as well as giving you the sizes of these different things, anything that you want to learn about, you can click on it and it will give you a bit more information. So there's information about all sorts of things, whichever types of things it is that you might like to have a look at. So information on all of them. Definitely worth a look at this website. So moving on to standard form then. Numbers in standard form are written as a number multiplied by a power of 10. This number is only allowed to take certain values. It should be a single digit from 1 to 9, and then a decimal point, and then any more digits that are in the number. So 3.2, 4.73, those are okay. You couldn't have 0 point something or 16 point something. It must be a single digit point something. And then the power of 10 has to be an integer. It can be positive, it can be negative. So have a look at these numbers. What do you think? Okay, let's have a look. This one, absolutely fine, because 3.7, that is a single digit point something, and we've got 10 to the power of -2, that's an integer, so that's fine. This one, the 8.5 is fine, but 10 to the power of 0.5, that's not an integer, so that one is not in standard form. This one, we've got 0 point something, that's not allowed. The power was an integer, but this bit means it's not in standard form. And finally this one, 11, that's not a single digit point something, it was an integer power. So in here, the only one which was in standard form was 3.7 times 10 to the -2. So some examples of converting. You should have done this before. There's lots of different methods. I've put a few examples here for you to take a look at, and using whichever method you prefer, I want you to have a go at converting these numbers into standard form, or converting from standard form back to decimals. Okay, times 10 to the power of 4, the way I think of it is that you've got the first digit and then 4 more digits before you get to a decimal point. So the first digit and then 4 digits, that will be 6, 3, 0, 0. We fill in with zeros if need be. And then there's nothing after the decimal point in this case because that's the whole number already. These ones, I find the easiest way, although you are dividing by 10 to the power of 5, it's easiest just to think of it as there will be 5 zeros before the numbers start. So 1, 2, 3, 4, 5 zeros, and then we start with the numbers given. Let's have a look at these ones here. So this big number here, we've got a 5 point, and then we've got 0, 7, 6. And then the rest are zeros, so we'll stop needing to write any values down. And then the power of 10 is just the number of digits after the first digit. So 1, 2, 3, 4, 5, 6, 7, so 10 to the power of 7. And here, again, using that slightly cheating method, we can just count the zeros. We've got the power is going to be 10 to the minus 4 because there's 4 zeros there, and the number will be 7.98. Pause the video and have a go at these questions. Here are the answers. Pause the video, have a go at these. So which is heavier? You might be looking at it and think, well, 5 is smaller than 8, so Uranus is heavier than Saturn, but the key thing is to look at these powers. 10 to the power of 26 is 10 times bigger than 10 to the power of 25. So that means it's going to move the digits into different place value positions. It's a bit like saying, compare the numbers 560 to 87. So even though 5 is smaller than 8, because it's in the hundreds place rather than the tens place, 560 is bigger than 87. This is what we've got, but with a whole load more zeros afterwards, but still the 5 is in the next column along from the 8, so Saturn is the heavier planet. Pause the video and have a go at these. And there's the answers. Pause the video and have a go at these. There's several ways you could do this. You might want to convert both numbers to standard form. So this number would become 3 multiplied by 10 to the power of 4, and then compare. We can clearly see then that 3 times 10 to the 5 is the larger number. The other option would have been to write 3 times 10 to the power of 5 in decimal form, and then compare 30,000 to 300,000 to be able to spot that 3 times 10 to the 5 was the bigger answer. So 1 billion. A billion is now, as a standard, 1,000 million. In the UK it used to be 1,000,000 million, but now it's 1,000 million. That is 1 times 10 to the power of 9. So 8 times 10 to the 8, just like the Jupiter-Saturn question, that's smaller than anything, well, any single digit, times 10 to the 9. So the billion is bigger. Here we've got 1 times 10 to the power of minus 4, which is a bigger number than 1 times 10 to the minus 5. If we were to write that out as a decimal, we would have that. So this is the bigger number. Over here, this is 0.006 compared to 0.005. So this time the digits are in the same place, So the fact that 6 is bigger than 5 does mean that that's the bigger number. Here's another sort of similar one. We have got 0.061 and the 6 and the 1 are in the same column, so 6 is bigger than 1. That means this is our bigger number. And here we've got differences in powers that are more important. 10 to the power of 17, that means this digit is a 4 with 17 zeros after it. And here we've got a 7 and then 14 zeros. So the bigger number is this one here, 4 times 10 to the 17.